Hello, just another example of proving a trigonometric identity. So my first step is always split it up into left side and right side. So the left side of the equation is secant x minus sine x over cotangent x. The right side, is 1 over secant x. So my first step is always going to be switched into sine and cos. So the right side looks a little easier, so I'm just going to do that quickly. The reciprocal of, so this is 1 over secant x. If you look at your definition for the identity, or the definition of the reciprocal trig function, it will be 1 over secant x is cos x. So this is just cos x. For the left side, I'm going to have 1 over cos x for secant. Sine x, so minus sine x on the top. On the bottom, it's cotangent x, which would be 1 over tan x, or if you think of it as just being the reciprocal of tan, tan is sine over cos. I'm going to write this up over in the margin. I'm not going to write it up here. Tan x is equal to sine x over cos x. So if I just take the reciprocal of that for cotangent x, then cotangent x can be replaced by cos x over sine x. And now I've got this problem again with a fraction with a fraction. So what I'm going to do is it's the same as division, but I'm going to write it as division just so it makes more sense, I think. So 1 over cos x minus sine x divided by cos x over sine x. So now when we're dividing fractions, we invert and multiply. So 1 minus cos x minus sine x times sine x over cos x. And it's sometimes tricky. Sometimes people have trouble remembering what to do when you're multiplying something that is not a fraction times a fraction. Just make this into a fraction over 1, and I think it makes it easier. So we would have 1 over cos x, and then minus sine x times sine x would be sine squared x. And in the bottom, I'd have 1 times cos x, which would be cos x. Oh, luckily we have a common denominator. So the common denominator here would be, it's cos x, we're already ready to go, so it would be 1 minus sine squared x on the top, all over cos x on the bottom. And we're still not quite to the right side yet, so I'm running out of space, so I'll go up here. If I look at the top, that is the Pythagorean identity rearranged. So sine squared, I'll write this down, so sine squared x, can I write this? Sine squared x plus cos squared x is equal to 1. So that's the Pythagorean identity. If I subtract sine squared x from both sides, I'll have cos squared x equals 1 minus sine squared x. So I can replace this 1 minus sine squared x with cos squared x, and that's kind of like an aside here. It's not part of my proof. So the left side will be equal to now cos squared x over cos x, and cos squared x over cos x, one copy of cos x will divide, so I'll be left with just cos x, which is the right side of my equation. So now I have left side equals right side, and my proof is finished. I hope that helps.